Hello and greeting. My name is McDevini Duli Anak Mikol, and I'm here to present the result of our group project titled Sound Graph Project under the subject Mathematics 2. This project was carried out by 5 team members from Group 23 under the guidance of TS Dr. Gede Pramudia Ananta. The main goal of our project is to explore the connection between sounds and mathematics, especially how sound wave can be represented using trigonometric function. Our project is divided into two main parts. First, introduction to sound wave. Second, introduction to touch-tone telephone. We study how sound waves, which are essentially pressure vibration in the air, can be modeled using the sine function yt equal to a multiply sin 2 pi ft, where a is the amplitude, f is frequency in hertz, t is time in second. We graph various pure tone like 800 Hz and 16 Hz, and also look at what happened when we combine them, including the correction of bit frequency.
For this project, we worked together as a team and everyone had their own part. Jared focused on the sound graphs and looked into bit frequency. McDevany handled most of the sign function part to help us understand how the signal works. I'm Calvin. I did the calculations and wrote the technical parts. Muhammad Rizlan helped gather data and research how DTMF is used in real life. Akram support the research and work on the visual for our report and video. We discuss everything as a group, make sure everyone was on track, and help each other when needed. In the end, all of us presented together and explained our parts clearly. It was a real team effort, and we are happy with how it turned out.
Hi, my name is Jared Xavier Anak Singot. My matrix number is CP240173, and now I will explain about the touch-tone telephone, which is we call DTMF. Okay, next. Right now we will explore how touch-tone telephone use dual-tone multi-frequency DTMF signals. Each number on a telephone keypad produce a unique tone, which actually a combination of two sine waves, one from a low frequency group and one from a high frequency group. For example, pressing the number 5 generates tone at 770 Hz and 1336 Hz. These combined signals are sent over the telephone line to represent the dial number. We also investigate why specific DTMF frequency were chosen. Which country use DTMF, such as the US, most of Europe and Asia. The standard tone for dial and busy signals. The additional DTMF keys A, B, C, and D actually are used in military and specialized systems. And lastly, we also investigate the concept of twist, which refers to the amplitude ratio between the two tones.
My name is Muhammad Akram bin Sami and my number matrix is CB240025. So, one of the biggest challenge that we faced was understanding how sound frequencies relate to the mathematical models. At first, it was difficult to interpret how different wave combination behave. However, with teamwork, online resources and guidance from our lecturer, we were able to solve these issues. This project taught us not only about sound and mathematics, but it also how math is used in real-world technologies like audio processing, telecommunication, and signal analysis.
Hello, my name is Muhammad Rizlan bin Guhadin and my number matrix CB240026. And that brings us to the end of our project. Working on the sound graph project was a really valuable experience for all of us. It allowed us to apply what we have learned in math in a fun and hands-on way. Along the way, we also improved our research and presentation skills. But most importantly, we learned how to work better as a team. Thanks so much for watching our presentation. We hope you enjoy it and found it both informative and interesting.